Okay, here we go. 9.3, number 9. X is 2 cosine theta. Y is 2 sine theta. So here, this is the first one we've had where the parameter is not t. It's okay, we can have a parameter that's anything. But here we've got a theta. Typically when I see a theta, I think that it is related to polar coordinates or something spinning. In this case, if I didn't have the 2's and x was cosine theta and y was sine theta, I would get the unit circle. You should recognize that. So what's the 2 do? It makes it so that it's a circle of radius 2. So if I were to ask to graph this, I would just draw a circle of radius 2. Anyway, let's start with finding dy dx. So dy dx is equal to dy d theta over dx d theta. So I will work this out because it's going to get confusing. Everything's the same when we have all these sines and cosines. Just have positives and negatives. Anyway, dy d theta is equal to, the derivative of that is 2 cosine theta. So I'm going to write that 2 cosine theta over the derivative of this, dx d theta is equal to, I get a negative 2 sine theta. So I'll put my negative there, sine theta. Well, take a look. That is, the 2's cancel, and it gives me cosine over sine. Well, cosine over sine is 1 over tangent, so that is negative cotan theta. You could write that as 1 over tan, be totally legitimate. So now we want to evaluate that at pi over 4. I'm going to write it with good notation. Dy dx evaluated at t equals pi over 4 is equal to, the reason I do that here, and the reason why this is not the greatest notation, is because it's like, well, what's pi over 4 if I write it like this? Is it x? Is it theta? What is it, right? That's why this is a better notation. Anyway, come over here. You should be able to think in the unit circle. I got pi over 4. That's right here. Okay? That's a 45-degree angle. And I'm doing cotan. That is 1 over tangent. Well, so if I could think about the tangent here, then I'm good to go. You should know the tangent on the unit circle is the slope. Well, that makes this problem easy because we are at a 45-degree angle, so the slope is 1. So what I get here is negative 1 over 1, which is just negative 1. So that's part A, well, what I'm calling part A. Okay, so from here, we want to find the second derivative of y with respect to x, and I want to do it at pi over 4 again. So I'm going to slide over here, because I'm going to use some of the things here that I already wrote. I'll do all my new work in red. So d squared y dx squared, that is d over d theta of dy dx divided by dx d theta. It's the same as the formula as when we had the t's, except for now the t's are thetas. If you're not sure as to why that formula makes sense, 1, you could refer back to the con that I had you guys watch, or 2, watch the last video, which was 9.3, number 5, I think, and I go in a little bit more detail. Anyway, so I need to derive this with respect to theta. This is a scenario where it makes sense to have a cotangent because I'm now trying to take this with the derivative with respect to theta. if I was trying to do 1 over tangent, I'd have to do some chain rule, and I don't want to do that. The derivative with respect to theta of negative, actually here, I'll write this out. So this is d theta of negative cotan theta all over dx d theta. I got to look back at my work. Dx d theta was here. Oh, it's right here. So that gives me a negative 2 sine theta. So from there, I just get rid of the negatives. They will cancel. Cancel, cancel. All right, now I have to do the derivative with respect to theta of cotan. Well, you should also know that. That is negative whoops, isn't that funny? Negative cosecant squared theta. How do I know that? Because tangent derives to secant squared, so cotangent, its pair, derives to the negative version of the opposite. So I remember it. So negative cosecant squared. And then I need to divide that by my 2 sine theta. Now, at this point, we want to simplify it before I try to evaluate it, because I'd rather keep it simple. In this case, I think that it's easiest to write things in terms of sines and cosines only. So, most just kind of sines and cosines. Cosecant is 1 over sine theta. That's what cosecant is. So that means that this, oops, wrong button. This is going to be a 1 over sine squared theta. So I get negative 1 over sine theta times sine squared theta, which is negative 1 over sine cubed theta. So at that point, I can't zoom out, but I now have the second derivative of y with respect to x, but I haven't evaluated it. So now I want to evaluate it pi over 4, so I'll go back down here. Remember, unit circle, pi over 4. Both sine and cosine are root 2 over 2 there. So, oh, I dropped something. I dropped my 2. My 2. Okay. So, from there, I need to do sine cubed. So that means that that I need to cube this root 2 over 2. So I get negative 1 over 2, open parentheses, root 2 over 2 cubed. That looks pretty terrible, I'm not going to lie. If this was a FRQ, we could stop. If it was a multiple choice question, I have to keep going. I'm going to sort of treat it like it's a multiple choice question because this is the kind of thing that the AP would ask. So I get negative 1 over, I got a 2. I've got, I'm going to write it as root 2 times root 2 times root 2 over the 2 down here cubed, that's 8. Actually, I'll write it as 2 times 4. Why do I do that? Because those cancel. From there, I get, you may just see it, 2 of these, this times that, actually I'll do first, this one times that gives me 2. Divided into there, I am left with just a 2 in the bottom. So I'm going to cross out these 2 and cross out that and write a 2. And now I'm going to reorganize my work because it's a total mess. I've got negative 1 over root 2 over 2. You may know what that is. It's just root 2. But what I can do here is multiply by the reciprocal, which gives me negative 1 times 2 over root 2. Copy dot flip for those of you who like that, which gives me, I can rationalize that, root 2 over root 2. And that, I'm almost to the end, gives me negative 2 root 2. In the bottom, I get another, undo, I get a 2. These cancel, so I just get negative root 2. If you're fast with this stuff, you might be able to do a lot of this work that I did from here all the way over to there quicker than I did there. But anyway, there you go.